Assalamu alaikum dear students. In the previous lecture we have studied about the classification of acids, and today we are going to study about the properties of acids, both physical as well as chemical. And first we will start with the physical properties of acids. Among physical properties I am going to discuss about the electrolytes. What are electrolytes? Electrolytes are the substances that conduct electricity in their aqueous state or in their molten state. I repeat, electrolytes are the substances that conduct electricity in their aqueous state or in their molten state. By saying this, I actually mean that if NaCl is taken as a solute in an aqueous solution, that is dissolving NaCl in water. This is water, some drops of NaCl or some crystals of NaCl, sodium chloride. If this solution conducts electricity in this state, aqueous state, it will be called as an electrolyte. So what electrolytes basically are, these are the substances that conduct electricity in their aqueous or in their molten state. We all know that pure water is a bad conductor of electricity. It does not conduct electricity, pure water. So if certain crystals of NaCl are dropped in water, the solution starts conducting electricity by just dropping some crystals of NaCl. So that means solution becomes conducting. As soon as it becomes conducting, by dropping NaCl acted as an electrolyte. That is the substances that conduct electricity in their aqueous or in their molten state. Now about the properties of acids. Acids are good electrolytes. Acids are good electrolytes. By this statement, I actually mean that when acids are dissolved in aqueous solution, they start conducting electricity. I repeat, when acids are dissolved in aqueous solution, the aqueous solution starts conducting electricity. So acids act as good electrolytes. So if we dissolve HCl into water, since water is a bad conductor of electricity, pure water, bad conductor of electricity, when we drop HCl into this water, the solution becomes conducting. So HCl is an acid. It acted as an electrolyte. So acids are good electrolytes. They start conducting electricity in their aqueous solution. Fine. Second one. Second one being that acids change the color of indicators. Acids change the color of indicators. Acids change their color. Fine. Acids change the color of indicators. By saying the indicator, what I actually mean is, indicators are these complex substances that show different colors in different acidic as well as in basic medium. I will repeat what indicators are. Indicators are the complex substances that show different colors in acidic and basic medium. They actually help us to know whether any substance is acidic or basic by changing its color. See, indicators are the complex substances. There are certain substances, complex one. that help us to know about the nature of substances. Nature of substances. Whether the particular substance is acidic or it is basic. How do I know whether they are acidic or basic? They change the color. Examples. There are so many examples of indicators, both being artificial as well as natural. Example. I will take the example of litmus. Litmus. We know litmus paper. Litmus paper, not litmus. It's a purple dye actually. Fine. I am talking about litmus paper. They come in two forms, red and blue. Red and blue. If blue change into red by dropping certain substance onto this paper, blue paper, it changes into red, we say the substance is acidic. And if certain substance is brought and put into on the red paper, it changes from red to blue, so the substance is basic. So by just indicating the color, we get to know about whether substance is acidic or it is basic. This is by the help of indicators. I will repeat what are indicators. Indicators are the complex substances that help us to know about the nature of substance, whether a particular substance is acidic or whether it is basic. How do I come to know? By these indicators change the color. They change the color of the substance that is being brought into them. Examples, litmus paper. We have one more example, methyl orange. Methyl orange is another example of indicators. One more example is phenolphthalein. Another example, red cabbage juice. We have so many examples and this will be dealt accordingly, this topic, indicators. Here we just know that acids change the color of indicators. They change the color of different indicators. Indicators are the complex substances that show us whether a particular substance is acidic or whether they are basic by changing their color. They help us to identify the nature of substance. Examples of indicators are litmus paper, methyl orange, phenolphthalein, red cabbage juice. Clear? Going ahead. The next property being acids do not show acidic behavior in absence of water. That is, we know acids are substances that when dissolved in water release H positive ions. Here we are saying acids do not show their acidic behavior in absence of water. By this statement we actually mean that if acids are brought in absence of water, will they release H positive ions? No, they won't. They will only release H positive ions in water. Fine. Example, to make it clear, dry HCl gas. Dry HCl gas, when brought and put on litmus paper, it doesn't change the color of litmus paper. Dry HCl gas doesn't change the color of litmus paper. It should change its color from blue to red because it's acidic. But in absence of water, it doesn't show its behavior. So acids do not show acidic behavior in absence of water. They do not show their properties in absence of water. Yeah, if they are brought into the water, what acids do? Acids, when dissolved in water, release H positive ions that exist as H3O positive ions, hydronium ions. This is the reaction, H positive plus H2O. Dative bond, or we can say coordinate covalent bond, results in the formation of H3O positive, that is hydronium ions. I will repeat my statement again. Acids do not show acidic behavior in absence of water. Means if a certain substance that is acidic in nature is brought and put on litmus paper, example dry HCl gas, it doesn't change the color of litmus paper. That means it doesn't show the behavior, acidic behavior which it should show. That is, it should change the color of litmus from blue to red, but it is not changing the color. That means it's not showing its acidic behavior. However, when acids are dissolved in water, in presence of water, they release H positive ions which exist as H3O positive ions, also called as hydronium ions. Here I am writing H positive plus H2 gives H3O positive. Fine. Looking at another property, that is whether the acids are corrosive in nature or not. We all know mineral acids are very strong. They cause severe burns on the skins and they cause holes on the materials we put on them. So the next property is acids are highly corrosive in nature. I am repeating, acids are highly corrosive in nature. Highly corrosive. Which one? Mineral acids like HCl, H2SO4. They are very corrosive in nature. What do? They cause severe burns on skin if they act on skin, if they are put on the skin. They cause severe burns on the skin. Fine. Even they attack and eat up the metal. So, as a precaution, we do not store acids in the metal containers. This is a question in an NCERT book, that why are not acids stored in metal containers? Acids are highly corrosive in nature. They react with the metal. So, they attack the metal, react with it and eat up the metal. We should not store acids in the metal containers. They eat up the metal. So they are highly corrosive in nature. Where are the acids then stored? They are stored in containers made up of ceramics or glass. They do not attack ceramics or glass. I am repeating from the very beginning, acids are highly corrosive in nature. Mineral acids like HCl, H2SO4, they are very reactive in nature. They cause severe burns on skin. God forbid, if they act on a certain skin, if they will put on the skin, they will cause severe burns. They attack and eat up the metal. They react with the metal in which they are put. So they are not stored in metal containers. They are stored in containers made up of ceramics and made up of glass. Hence, we should prevent acid to be stored in metal containers. One more property about acids is their physical state. Physical state means whether acids are solids, they are liquids or they are gases. Acids are usually and generally found in solid as well as in liquid state, not in gaseous state. Fine. Acids are usually found in solid or in liquid state. Clear? Acids are usually found in solid and liquid state. Examples. We all know boric acid, H3BO3. It is found in solid state. Fine. Oxalic acid found in solid state. And in liquid state, we have best examples, HCl, H2SO4, HNO3, nitric acid. These are the examples of acids that are present in liquid state. So in general, acids are usually present in solid state, example boric acid, oxalic acid, and sometimes they are present in liquid state, example HCl, H2SO4 and HNO3. The last property being the taste. Taste. How do they taste? We all know that acids should not be tasted nor they should be touched, as they are highly corrosive in nature. I have discussed point of corrosiveness of acids. We studied they are highly corrosive in nature, so it should not be tasted or touched. Taste. How do acids taste? We all know acids are sour in taste. Acids are sour in taste. Fine. Mineral acids like HCl, H2SO4, they are highly corrosive in nature. They are very corrosive in nature. They should neither be tasted nor be touched. Highly corrosive in nature. So, they should neither be touched nor tasted. However, certain acids like citric acid, tartaric acids, they are present in our day-to-day life. That is example oxalic acid, citric acid, found in lemons, orange, and the next one, tartaric acid, found in tamarind. So, taste. Acids are sour in taste. Mineral acids like HCl, H2SO4 are highly corrosive in nature. They should neither be tasted nor be touched. However, certain acids that we see in our daily life, like fruits we eat, citric acid, orange, it is present in orange, lemons, and tartaric acid is present in lemons. So, in general, we studied about the physical properties of acids. The first one being they are highly corrosive in nature, second one being their taste, third one being their physical state, fourth one being the electrolytes, they act as good electrolytes, fifth one being they are highly corrosive in nature. So, this was about the physical properties of acids. Now, looking at chemical properties of acids. What will be the chemical properties of acids? Chemical properties of acids. That is, what happens when acids react with metal? What happens when acids react with metal? So, my first property among chemical properties is what happens when acids react with metals. So, this is a reaction of acids with metals. Fine. When acids react with metals, they form metal salt and release hydrogen gas. I am repeating, what happens when acids react with metal. Acids react with metal and form metal salt and release hydrogen gas. Clear? Acids. Example, H2SO4. Okay? Then the metal, Zn. Metal salts, ZnSO4, zinc sulfate, and there is evolution of hydrogen gas. Fine. Another example, H2SO4 with magnesium gives MgSO4 plus H2. Fine. Okay. Moving ahead, HCl with zinc. Fine. It will form zinc chloride and release hydrogen gas. By balancing, just putting 2 over here. Again, HCl with magnesium chloride releasing hydrogen gas. So, in general, when acids react with metal, they form metal salt and release hydrogen gas. Salts, talking about salts. If we take sulfuric acid, the salts so formed are called as sulfates. Sulfates and the metal. So, this will be metal sulfate, zinc sulfate. If we take HCl, the salts so obtained are chlorides. Fine. Example, zinc chloride, magnesium chloride. Fine. Add HCl plus Ca, calcium gives calcium chloride and releases hydrogen gas. Fine. So, the salts formed with sulfuric acids are called as sulfates. The salts formed with HCl are called as chloride, that is magnesium chloride, zinc chloride. So in general, what happens when acid react with metals? They form metal salt and release hydrogen gas. Now looking at the property number second, chemical property number second of acids, that is what happens when acids react with base. Fine. Second chemical property being what happens when acids react with base. We have studied this in our chemical reaction and equation chapter. This reaction, what happens when acid react with base? We all know when acids react with base, they form salt along with water. And this reaction has a particular name called as neutralization reaction. I am repeating, when acids react with base, they will form salt along with water. The reaction is called as neutralization reaction. Fine. Here I am writing acids react with base. What do I get? Salt along with water. Salts, acid, HCl, base, NaOH, sodium hydroxide, salt, our sodium chloride, and there is evolution of water, H2O. Fine. I am repeating what happens when acid react with base. This is general reaction. Acids react with base, they form salt and release water. Acid is HCl, base is sodium hydroxide, salt is sodium chloride, and there is evolution of water. Fine. This reaction is also called as neutralization reaction. Neutralization reaction. Clear? The example, H2SO4, NaOH gives Na2SO4 plus H2O. Fine. Clear? So, what happens when acid reacts with base? Acid reacts with base to form salt along with water. This reaction is also called as neutralization reaction. Inshallah, in the next lecture, we will be discussing more about the chemical properties of acids and then about the bases. Assalamu alaikum.